Okay, this video is designed to answer some questions about finding the maximum values. I've had a few students been continuing to ask about the maximum values for the polar graphs that we're doing. So again, this video is designed to help address that question because it's come up a lot of times. So to find the maximum R value for most polar graphs, you would find the values that make sine of theta and cosine theta equal to 1 and or -1. And it's and or -1 because sometimes it's one or the other. Like sometimes I just want cosine to equal 1 or I want cosine to equal -1. But sometimes it's both. And so that's why I literally have and or. So the rest of this video, I'm going to look at some examples of different equations we've seen and just go through how to find the maximum values, trying to explain as I go. So the first equation is r equals 5 minus 2 sine theta. You might recognize this as one of our forms of a limacon. But it is just a polar graph, and it's a graph that I can find a maximum value for. Since sine theta as a maximum can only be equal to 1 or -1, then my equation is either going to be 5 minus 2 times 1, or it's going to be 5 minus 2 times -1. Because sine theta could be smaller than 1. Sine theta could equal 1/2 or square root of 3 over 2 or 1 divided by square root of 2. The range of the sine function is between -1 and 1. So the most positive sine theta can be is 1 and the most negative sine theta can be is -1. So if I look at these two equations, I'm either going to get 5 minus 2 is equal to 3, or I'm going to get 5 plus 2 because of -2 times -1, so r equals 7. So my maximum value is r equals 7 at some angle theta. And so we want to find theta. Or if there's a multiple angle, like an n theta, a 2 theta, 3 theta, 4 theta, I want to find all of the angles theta that's true. So we need, for this problem, we need sine theta to equal -1. And as I go through these examples, if I don't answer a question you have, go ahead and write down that question, and then instead of doing some basic things tomorrow in class, we can go over your very specific questions about what part of this process you're still having trouble with. To solve sine theta equals -1, I do the inverse sine of both sides. So I get theta equals the inverse sine of -1. So where does the sine function equal -1? This goes back to my trig graph. And we're looking for an answer from -pi/2 to +pi/2. So the inverse sine of -1 is -pi/2. So I could say that theta is -pi/2. I could also say that theta is equal to 3pi/2 because that's a coterminal angle. And when I'm doing these polar graphs, it doesn't really matter if I'm talking about the negative angle or the positive angle because we know that that's still the same point. So my maximum value could be 7, -pi/2. My maximum value could be 7, 3pi/2. Those are 2 of the 4 ways to name that point. And we talked in lesson 1 of this unit about what are the other 2 ways to name that point. Well, I could call it, let's see, so we said we could do pi/2, -7. Okay, if we really wanted to, but there's no point there for this. So that's how I find the maximum value for this problem. Another example, this one's much like the first example, so if you want to skip ahead, you can. But again, cosine of theta is going to equal either 1 or -1. So my r value is either going to equal 4 plus 3 times 1, or it's going to be r equals 4 plus 3 times negative 1, because the range of the cosine function is between negative 1 and 1. And so the most positive number that cosine theta can equal is 1, and the most negative it could be is negative 1. So if I use positive 1, I get r equals 4 plus 3, which is r equals 7. If I use negative 1, I get r equals 4 minus 3, so r equals 1. So my maximum is going to occur at 7 comma theta. So find theta. This time we need where cosine theta is equal to 1. So we take the inverse cosine of both sides and we say cosine or theta equals the inverse cosine of 1. And this goes back to the definition for where we defined inverse cosines in unit 1. So my cosine curve looks like that. And we specified that the cosine curve was going to go from 0 to pi on my restricted cosine function domain. And so between 0 and pi, where does cosine equal 1? When my angle is 0 degrees or 0 radians. So my maximum is going to be at 7 comma 0. 0 degrees or 0 radians comma 7 for my r value. So 7 away from the pole at the angle 0 radians. This is an equation of a rose curve, a sine n theta. And so let's look at the multiple angle problem we have, sine 3 theta, and do the same thing. One of the lessons that we did in Unit 3, we spent one day talking about the difference between y equals sine x and y equals sine 3x. And the difference between y equals sine x and y equals sine 3x is that I'm going to repeat this function 3 times between 0 and 2 pi. That's what the 3 in front of the x does because it's a horizontal shrink by a factor of 3. Now the maximum values are still all at 1 or negative 1. So the most this can be is either 1 or negative 1. So r is either going to equal 4 times 1 or r is going to equal 4 times negative 1. And we should consider both, which is different from the previous problems, because in the previous problems, there was only one r value that was biggest. R is 7, not 1. Here, I could say the absolute value of r is equal to 4. R is either equal to 4, r is equal to negative 4. So on a graph, on a polar graph, if I graph a negative 4, that's the same distance away from the pole as positive 4. And so the absolute value of r is still 4. So the question is, what are these x values? This is x comma 1. What is that? This is another x comma 1. What is that? This is another x comma 1. What is that? This point down here is an x comma negative 1, etc. And so we're trying to figure out what are those angles that make that happen. And that was the point of this lesson. We did this lesson, I designed this lesson to only talk about the period of the trig function and the horizontal shift so that the next day when we solved multiple angle equations, there is a background in your brain of why we have these multiple answers. So I think some of the questions have been coming in because maybe we're not clear on this multiple angle solving. Because now I need to solve the equation, where does sine 3 theta equal 1? So I'm going to take time in this video to explain that, because in class, it's assumed you know. This is unit 6. Sine 3 theta equals 1 was a unit 3 topic. It is assumed right now that you know how to do this. So I'm going to use this video to go back over that. So I'm going to take the inverse sine of both sides, which tells me that then 3 theta is going to equal the inverse sine of 1. And I should say that I also have to do this for negative 1. So right now I'm focusing mostly on this 1, and I'll focus on the negative 1 in a moment. We already said in this video that sine inverse of 1 is at pi over 2. And when you are solving a multiple angle problem, you solve it for the general solution. So the specific solution is pi over 2. But then we know that that happens every 2 pi n. So if my period normally goes until 2 pi, and then it repeats itself, this maximum value of 1 at pi over 2, should write that the other way, used to writing polar, is also going to happen pi over 2 past the 2 pi. This distance between these is 2 pi. That's the period. So every point repeats 2 pi units later. So pi over 2 plus 2 pi is pi over 2 plus 4 pi over 2, which is 5 pi over 2, comma 1. And then there's another one, another 2 pi units away, and we find those values. That's why there's a plus 2 pi n. If you didn't know that before, maybe that's, hopefully you know it now. Because the last thing I really want you to do is to follow a formula or a rule and not have an understanding of where it comes from. So we say plus 2 pi n because that's going to show every other point on the function that has a sine value equal to 1. And then we solve. So we divide by 3. And theta is equal to pi over 6 plus 2 pi n over 3. Or a lot of times, many of us like to write it as pi over 6 plus 4 pi over 6 n, because it's easier to add. And so this is telling me these points that at pi over 6, 1 plus 4, so 5 pi over 6, 5 plus 4, so 9 pi over 6. And if I go plus 4 one more time, I'm outside of my area of 0 to 2 pi. That every single time I do this, I'm getting a sine value equal to 1. So my r value is equal to 4 times 1. So my r value is 4. So those are 3 of the maximum values for this polar graph. The other ones are going to come from when sine is equal to negative 1. So sine 3 theta equals negative 1. We take the inverse sine of negative 1. And that tells me that 3 theta is equal to negative pi over 2 plus 2 pi n. Because on my original trig graph, where we defined the inverse, it was equal to negative pi over 2. And then I just showed you that every one of the points repeats itself 2 pi units later, because that's the period of the sine function. We also talked about another way of learning that, which was to say, if I look at this as negative pi over 2, and this is where sine is equal to negative 1, when I say plus 2 pi n, I am adding a coterminal angle. Because when I add plus 2 pi radians, I'm going once around a circle. So plus 2 pi, n times is the number of times I'm going to go around the circle. So that's a second way to understand why we are adding 2 pi n. So then I divide by 3 and get theta equals negative pi over 6 plus 2 pi n over 3, or negative pi over 6 plus 4 pi n over 6. And I could use negative pi over 6, but all my other values are positive values, so I'm just going to start by adding the 4 pi n over 6. So negative 1 plus 4 is 3 pi over 6. And 3 plus 4 is 7 pi over 6. And 7 plus 4 is 11 pi over 6. And on each of these values, our sine equals negative 1. So 4 times negative 1 is negative 4. And those are all the maximum values for this polar graph. Now, as a rose curve, whether or not I list out these points and all 6 of these points identify 6 unique points, or whether they identify 3 points and then they actually repeat the same 3 points, that determines whether or not there's going to be 6 petals or 3 petals. And if you know that, that's great. If you know, looking at this, that, oh, those are just going to repeat, so it's just going to be 3 petals. Because all of the negative ones actually get graphed back onto the ones we graphed as positives. So graph all 6 of those. Graph them in 2 different colors. Look at the way they overlap compared to a rose curve with an even n theta, like this one. So 6 cosine 4 theta. I'm trying to go slow through this concept because a lot of people have been asking about how to find the maximum. Cosine of 4 theta still is just going to be 1 or negative 1. So r is either going to equal 6 times 1, or r is going to equal 6 times negative 1. Because cosine 4 theta, just like cosine theta, has a maximum value of 1 and a minimum value of negative 1. And one way to draw the graph is to say the parent function, this would be 2 pi. But if it's not the parent function, if it's actually cosine 4 theta, then 2 pi divided by 4 is pi over 2, and this would be pi over 2. All I did is change the horizontal scale. The vertical aspect of the graph still goes between negative 1 and 1. And cosine also repeats itself every 2 pi. The distance between those is 2 pi. That's why we add 2 pi n. So cosine 4 theta is equal to 1. Cosine 4 theta is equal to negative 1. If you know more, like you know that this is 4 theta, so there's going to be 8 petals to your rose curve, there's going to be 8 maximum points that all matter, then you could say cosine 4 theta equals plus or minus 1. Then when you go to solve, you'll have one equation instead of 2, and I'll use that as an example here. So 4 theta equals the inverse cosine of 1 So 4 theta equals 0 plus 2 pi n, because cosine equals 1, it's 0 radians. Or 4 theta equals the inverse cosine of negative 1. So 4 theta equals pi plus 2 pi n. I can combine those equations into one equation. 0 plus 2 pi n and pi plus 2 pi n is the same thing as 4 theta equals pi n. Okay? If I plug in 0 for n in my purple equation, I get 0, which matches my blue. If I plug in 1 for n, I get 4 theta equals pi, which matches my red. If I plug in 2 for n, then I get 4 theta equals 2 pi, which would be the same thing as my blue equation when n equaled 1. If I plug in 3 for n, 4 theta equals 3 pi, which is the same as if I plugged in 1 for the red equation. So if you want to, you could put them into the same equation and solve that. So theta equals pi over 4 times n. So when n equals 0, theta equals pi over 4. When n equals 1, when n equals 0, theta equals 0. When n equals 1, we get pi over 4. When n equals 2, we're going to get 2 pi over 4. We're going to get 3 pi over 4. We're going to get 4 pi over 4. We're going to get 5 pi over 4. We're going to get 6 pi over 4. We're going to get 7 pi over 4. And we've already said 2 pi because 2 pi is the same thing as 0. And some of these are going to be positive values and some of these are going to be negative values. So on the Unit 3 test, I asked you to do this. I asked you to solve a multiple angle equation, give me the general solution, and give me all the specific solutions. And I've been going back and looking at homework, and some people didn't even do that on the homework. So like you're maybe have missed something from that unit. And if you want to figure out, well, which one of these are ones and which one of these are negative ones, well, then maybe we should have solved them separately. But basically the evens, 0, 2, 4, 6, 8, okay, those are going to come from the positive 1. You can go back and look at the blue equations. And my equation originally was 6 times that. So 6 comma 0, 6 comma 2 pi over 4 or pi over 2, 6 comma pi, because that's 4 pi over 4, 6 comma 6 pi over 4, negative 6 comma pi over 4, negative 6 comma 3 pi over 4, negative 6 comma 5 pi over 4. And if you don't want to try to figure out which ones are which, then don't do the purple equation. Just keep it as 2 separate equations and get your answer. And then our last one is going to be r squared equals 3 sine 2 theta. So by now, hopefully we know that this is either going to be 1 or negative 1. So my r value is going to be r squared equals 3 times 1, or r squared equals 3 times negative 1. Now for this one, let's take a look at that for a second. Because this says r squared equals negative 3, so then r equals the square root of negative 3. And as far as polar goes, with what we're doing right now, we are not going to do that. So the negative 1 doesn't apply for the sine value. Now for the other equation though, r squared equals 3, my r value is going to equal plus or minus the square root of 3. So I'm still going to have a positive and a negative, but it's coming from somewhere else. Because when we take the square root, we need the positive and the negative. But to get those r values, we're going to find where does sine 2 theta equal 1. So where does 2 theta equal the inverse sine of 1? Well, that means 2 theta equals pi over 2 plus 2 pi n. And when I divide by 2, I get pi over 4 plus 2 pi n over 4. And what's different about the lemniscate, which is what this curve is, as evidenced by the 2 theta on the inside as well as the r squared, that combination of the r squared and the 2 theta show that when I do the plus and minus root 3, the points repeat themselves. They lie on top of each other. We just use the same 2 points twice. So the points are going to show up, if I wanted to write all the points, they're going to show up as pi over 4 comma, or root 3 comma pi over 4 and negative root 3 comma pi over 4. Like those, it's r equals plus or minus root 3. Root 3 from the 3 times 1. And then if I add the 2 pi over 4, then I have 3 pi over 4. So I'm going to have root 3 comma 3 pi over 4 and negative root 3 comma 3 pi over 4. Oh, I did that again. I'm going to go back up a step. You may have already noticed it, and if so, good for you. When I divided by 2 right here, I should have probably written it down. Divide by 2, divide by 2, divide by 2. I did that earlier today as well. The 2 divided by 2 actually gives me a pi n. And the reason I was checking that is because my angles didn't make sense to me, because right now I have a quadrant 1 angle and a quadrant 2 angle, but where are the others? So pi over 4 plus pi n would be 5 pi over 4. And you may have already noticed that. And so this actually only creates 2 points on the graph because the top point and the bottom point are located in the same spot. So that is a 27-minute explanation on maximum values. And if you still have a question on maximum values, you're going to have to be very specific with your question so that I can help you the best.